All right, so this is an illustration of how you might go about conducting an analysis of the N2pc component using Brainstorm. The first thing to note is that I've already binned the continuous data to extract the relevant target stimuli, that is, the targets that are on the left or targets that are on the right, and even separated those by an experimental condition of high and low value targets. That'll allow us to address some questions about the N2pc component. The other thing to note is that I've already created subject averages for each of those conditions, as well as grand average. So the first thing we need to do is apply the contralateral minus ipsilateral montage to create that measure of the difference between the activity on the hemisphere that's contralateral to the target stimulus minus the activity ipsilateral to the target stimulus. So to do that, we'll first take down the target left conditions. And if we don't want to use the grand averages, which is the case here, we'll go ahead and select just those subjects instead and exclude the grand average from the analysis. So here's the target left for high value and the target left for low value. And I'll pull each of those down. Now you'll notice that the trial count shows that I've got individual trials in here instead of just the subject averages. So you might want to go in here and use the filter to select only those average files for each subject. You can see that everybody has one file now. The next thing to do is to click Run, and then we're going to select the standardize option here in the process dialog. Whoops. And then once we get to standardize, we're going to go to apply montage. Now in this case, I've already loaded the relevant files, those montage files, into my protocol. So you can see that they're listed here. I've got a left minus right protocol or montage and a right minus left montage. In this case, I'm analyzing the data where the targets are on the left. So contralateral would be right and ipsilateral would be left. So I'm going to want the right minus left montage to be applied here. And in most cases, it's easiest if you just create new folders after these montages are applied. That way you can work separately with and very easily with the montage data. After you've applied the montage, you may want to apply some other processes. I usually like to go ahead and make sure that the data are baseline corrected after I've done the new montage and the subtraction. So we'll go ahead and add a preprocess, remove DC offset. And in this case, this is the response to a target stimulus. So I'm going to go ahead and make this something like minus 100 to 0 as my baseline measure. And in this case, we'll just overwrite the files. And then after I've applied the montage, done the baseline subtraction, then I can go ahead and create new group averages for each of the two folders. So we'll go ahead and set an average files, and this time we'll want to group by folder and create a grand average over all the subject differences. Go ahead and click Run. And you can see this process takes a little while, so I'm going to go ahead and pause the recording. Okay, so now the process is just about completed. And what you'll notice when you're finished is that you now have duplicate folders for the target left target stimuli, but now one of those will have, for each of the conditions, will have this appended to the file name whatever the name of the montage is that you ran. So in this case, I ran the psych413 underscore right minus left montage. So I get a new folder containing the targ left norm high value correct trials, but with that montage applied, and the same for the targ left norm low values. And because we did the averages, you'll see that we already have the file for each subject with the montage applied and an average waveform. So the next step is now to apply the appropriate montage for the right-sided targets. So in this case, we'll grab the target right and target right for low value. Again, we have the averages filtered, so everybody should have one file. And these are targets on the right. So the montage that we'll want to apply through the standardized process is going to be, instead of right minus left, the contralateral will be left and the ipsilateral will be right. So we'll get the left minus right montage. After that, go ahead and pre-process, remove DC offset. We should probably do the same that we selected for the first round. Overwrite input files, and then create the averages, the grand averages by folder. So I'll let this run. I'll go ahead and pause the recording again, and we'll see in a minute. Okay, so now this is wrapping up. And one important thing to remember now is that once these montages have been applied, the distinction between target left trials and target right trials is essentially moot, because we've used the contralateral minus ipsilateral rule so that responses to the target stimulus, whether it's on the right or the left, can be combined as they both represent this contralateral minus ipsilateral subtraction. So here are the new folders that were created with the left minus right and right minus left montages applied. And the next thing now is, since we have target left for low value, let's say, with the contralateral minus ipsilateral montage applied, and we have target right with contralateral minus ipsilateral montage applied, we can now average these two together to get a combined measure of the response to to target stimuli for the low value condition. So in this case, let's go ahead and take the left low value, and you can see we've got an average file. So we're going to take all of the subjects from the low value condition, and target right low value, take those subjects, and now we'll go ahead and create an average files, but we're going to do it by subject. And this will create an average of the two for each of the subjects. Okay, so now that's finished, and what you'll notice is that these new average files will show up in an area of the Brainstorm protocol called intra-subject, and that's because the files were averaged by combining files from two separate folders. So we've got the files now. Each of these is the average here for the contralateral minus ipsilateral for low value, and then we'll just do the same thing for the high value. So I'm going to go down here, grab target left for high value. And target right for high value. And we'll just do the same thing. One thing to note, the output of these averages doesn't have a very much of an identifying marker to remind you of how what the data represent. So for example, there was no low value marker on there. So what I'll show you is that sometimes it's nice after you've done your averaging, so average by subject, then another thing you can do is to use the file process and go ahead and add a tag to these. So we could call this is going to be the high value, so we could call it targ high value contra minus ipsi. And this will just add it to each of those files. So I'll go ahead and run this. And now we have, for each of our subjects, again, within that intra-subject folder, we have a new one, the weighted average with two files, but this time you'll see that it has the tag targ high value contra minus ipsi. Now, for this version, it would have been nice if we had done that for the original so that we'd know that this was low value later on, but we'll just keep in mind that that's the low value condition. Okay. So then, in the group analysis, we have right now this Q average, but what we want to do is create grand averages of each of these two files. So the first thing I'm going to do is, let's see, we want to grab for each subject just the high value condition. So I'm going to take those subjects, and we'll clear the list out here. Bring those subjects down. They have two averages now. We don't want to average them all together. So let's go ahead and select the files that have HV in them. And right now we can see that it's selecting all the high value averages. And I'm just going to go ahead and do a quick average of all the subjects. So this will be everything, or by folder would work with the grand average. So we'll just say we're going to average everything, and then make sure we add a tag to this. So let's go ahead and add the tag targ HV contra minus ipsi. Now, in order to get the low value average, in this case, we can, because there are only two, we can just set to exclude the high values, and now we're only selecting the low values. So we could do the same thing, run the average files, we're going to average everything, and then when we're done, we're going to add a little tag here, and this will, instead of high value, be for the low value targets. And now we have two grand average waveforms, and we have the individual subject waveforms that we can use to measure. So first thing to do, let's go ahead and open these up. There's our low value and high value contralateral minus ipsilateral differences. Get the 2D disk. I should mention something I like to do. Not everyone, this isn't necessary, but if you have I channels listed in here, you may want to get rid of them because they can alter the way the topography is displayed. So let's see. So they're not included here. And that shouldn't be the case because in my montage I didn't include the I channels. Okay. So got our butterfly, and then we can just start walking along. So remember, target onset is at 0, and what we're expecting is that at about 200 milliseconds, according to the literature, we should start to see a negativity. That is, a contralateral, when you take contralateral minus ipsilateral, it should show up as a negativity at about 200 milliseconds, and then sometimes resolving around 400 milliseconds. So if we go along, and that contralateral activity should be over posterior recording sites like P07, P08, kind of in this region. So as we start to move along in time and we get to about 200 milliseconds, what we should start to see here is a nice blue negativity here representing a negative deflection over the posterior parietal sites that reflect this contralateral minus ipsilateral negativity that's happening. Again, remember the way I've done these montages, the left and the right side of the head are simply mirror images of each other. But you can see here that we've got a pretty good measure of what looks to be like a nice N2pc back there at the posterior electrode sites. Now, an additional question is whether or not the N2pc is any different for high value and low value targets. And in order to get at that kind of a question, of course, we're going to need the individual measures from each subject. In this case, too, we know where on the head we're looking to measure these things. So if we display the labels, you'll see that P7 and P8 are where we're seeing this N2pc displayed. So this is nice for visualization, but for testing, we really only need to look at electrodes P7 and P8. So in order to do that, let's take a look at the process 2. And in this case, we're going to need to separate out the individual subjects here because each subject has a file from each of the two conditions in this folder. I'm going to go ahead and open all these guys. And then what we want to do is go back to the top. So we're going to get the low value, sorry, that's the group analysis. So we want the high value for each subject. And we'll put them on one side, and then we'll go back and get the low value measures. Put them into files A, and now we have a collection of, and we'll have to get rid of this filter. So we should have one file for each subject on the left and one file for each subject on the right, which we can see over here. And then we can see from the plot, we're probably most interested in the time range between, say, 200 and 600 milliseconds. So let's go ahead and run our statistic. We'll do the test. We can do a permutation test paired because we have one measure from each of the conditions for all the subjects. So each subject contributes one file to files A and one file to files B. And then maybe we'll go ahead and restrict the range here a bit. I'll say we'll test between 150 and 650 milliseconds. We can average over the selected time window if you want. So in a little more exploratory approach, you can leave this unchecked and it will conduct the test at every single time point separately. So we'll go ahead and do that now. Paired test, 1,000 permutations or randomizations for this permutation test. Go ahead and click run. We'll get our perm test paired results right next to our grand averages. Go ahead and open that. We have to unload the other files. And what you can see here is that right after 200 milliseconds, there's some statistically significant results. Let's see here if I go ahead and create a 2D display. So at about 200 milliseconds, there's some slightly significant differences there. There may be a couple here. If we use the correction for multiple comparisons, we may lose some of this. But if we're right now looking at the uncorrected, and significance level is set at 0.05. So looking at this analysis, it looks like, although there are a few significant results in there at each time, that probably there's not a real significant difference between the N2pc for when compared with high value versus low value targets. And another way to visualize this, by the way, so if we go ahead and open the high value and low value targets again, we can always just create a cluster. And for that cluster, we could use electrode P7. Remember that P7 and P8 are identical because the two hemispheres are mirrored, so it doesn't make any sense to plot them both. But we could create a cluster for electrode P7 and then overlay the files, doesn't matter if we overlay the clusters, and make a plot of that as well. And then we can see by comparing directly the N2pc as it's measured from electrode P8 in any case, that there really isn't much of a clear difference between the two different conditions. So even if we apply some pretty aggressive filters here and smooth the data out, it doesn't seem as though there's a large difference in the terms of the N2pc component. So that's a full demonstration of how you might go about taking apart the different aspects of the analysis for the N2pc, and I hope you found it helpful.